think it's a few seconds short of 10:30. Figure everyone's here, ready to go, so we'll just get started. Hi everyone, I'm Vlad Giverts. I'm currently Senior Director of Software Development at Workday, which is totally meaningless. It's one of those like lofty corporate titles. Previously, I was the CTO at Identified, and that's where the technology we're talking about today kind of emerged out of. And this is specifically addressing some of the challenges that we had, and I'll get into that in a second. So we ended up giving this technology a name because, as a startup, we needed good PR, so we wanted to have something catchy. So we went with Simon for systematic mass normalization. And it allowed us to learn the semantics of a certain kind of entity that I'll get into in a second. In fact, we even we branded this technology. We gave it a robot, gave it a logo, and because that helped us actually communicate it out to kind of lay people. I didn't quite understand what we were doing. So the story started about 3.5 years ago, and it had a lot to do with what we saw as professional data. So, no, not that data, though he looks very professional. No, this kind. So we realized that there's an immense amount of professional information on the internet. This particular site was just one of them, but actually there's quite a few others. If you knew how to look for it, you could find them on all the big social networking sites, people talking about where they worked, where they studied, maybe even what they're good at. A lot more professional info as well on kind of what we're now calling vertical social networks, but where you see a lot of information about people, but it's focused around a particular niche. I don't know if you've heard about any of these other than GitHub, though that one's pretty common. There's actually a third major source of professional data online, and that's corporate team pages. So it's pretty common for startups to go and just literally list out the whole team of people on their sites. Actually, larger corporations do it as well. They'll often only list their executives. And what we can do then is take all the data, from the big social sites, the vertical social networks, the team pages, and just slurp them all up, aggregate all that data. And that's what we did. We did that about 3 years ago at Identified. We ended up aggregating well over 1 billion profiles, social profiles, public profile pages from all over the web. Ended up creating the single identity of record for people. And there's a lot of things we wanted to do with it. We wanted to create this incredible career path exploration tool for people. We wanted to give companies these predictive insights based on the information now, because knowing a lot about where people work and what they study gives a lot of supply and demand information. Unfortunately, our technology wasn't ready at the time to deal with that. So instead, we decided to monetize in a very simple way as a recruiting product. We just let recruiters search for and contact people they wanted to hire across this vast database that we had assembled. And because we were incredibly creative, we wanted to come up with a very, very creative name. So we called the product Identified Recruit. Now, unfortunately, it didn't work out as well as we hoped. So we gave recruiters access to the product. We did a pretty good job building out all the informational retrieval systems. We knew about search and facets and TF-IDF and all that nice stuff. I actually used to build search systems in another life. Years ago, I was the search architect at a company that was once known as Tagged, where they had, at that point, probably like 100 million users in their system that they, needed to be searched on constantly. But for whatever reason, our customers weren't able to find people they wanted to look for, at least not in the volumes. Now, we knew the data was there because we'd looked at it. We knew we had far more data in a lot of industries than, say, LinkedIn, but somehow we couldn't bring it to the surface. It turns out that if you're doing keyword-based searches, well, those keywords actually have to appear in what you're searching on. And the problem was that for job titles, for skills, for university majors, there was a really fat tail. In fact, it's hard to even call it a fat tail. It's just all over the place. To give you an example, if you're looking for software developers, what might they be called? Well, you could be a ninja coder, or you might be a code monkey, or you might be a monkey ninja coder, whatever it might be, or you might be like member of technical staff, or staff programmer 3, and it turns out there are easily hundreds and sometimes thousands of variations on job titles, and same for skills and university majors, that all mean the same thing. So how do we deal with that? We considered, the traditional approach is, hey, like query expansion. Our customers are doing the work for us. They'll try something, maybe they'll try another search, do Boolean queries. Unfortunately, because our product wasn't yet good enough to attract a lot of customers, we didn't really have the volume to make that happen. And even then, because as I alluded, there's this, so much freaking variation that query expansion wasn't even going to take you that far. So what did we do? We actually focused initially on the healthcare industry. So we thought, what? Let's try to get a grip on this problem. Let's see if we can just analyze the data and make sense of it manually. So we picked healthcare because we thought, hey, where's LinkedIn and everybody else in the tech industry not looking? And everyone in the tech industry is typically looking at tech recruiting. So we thought, hey, what about healthcare recruiting? That's the fastest growing industry in the country. They can't hire, and actually there's not that many healthcare professionals on LinkedIn who we're competing with. So, and then specifically we focused on nurses. And in fact, unfortunately, this is not what we were staring at all day long. What we were staring at all day long was more like this. So we had a too many nurses problem, and not the good kind. We easily, again, this is just a sampling of some of the nursing job titles we were dealing with, but this is not what we want to present to our customers. Ideally, our customers' mental model will look something more like this. Nice, structured hierarchy. Pretty much every major job title in nursing will fit into one of these boxes. And that's actually what we did. We went ahead and manually spent literally like 3 months looking at tens of thousands of nursing-related job titles and mapped them into this hierarchy. Quite laborious, didn't scale, but we just wanted to know if it was if there's any benefit to it. And it was. Immediately, our healthcare sales took off. All of a sudden, the product was useful because we had a really big synonyms table. But that wasn't scalable because we wanted to do that across all just US job titles, of which there were millions of distinct job titles, after some basic text normalization. That would take us hundreds of man years. If we just extrapolate out what it took us to do this. Even if we got more efficient and built some tools, maybe we'd get it to, 800 man years. It just wasn't going to fly. So we had to come up with an approach that was going to work. So we had these job titles. There's a handful of nursing ones. We tried different ways of using machine learning and labeling them and seeing if we can come up with algorithms that can then kind of infer the synonyms table so we don't have to do quite so much work. And we hit a lot of dead ends. But one of the insights we had was that, well, even though, yes, all these job titles are very different, and oftentimes they don't have enough terms in common for all of them to be surfaced simultaneously, they do have n-grams in common. So if you look at this, we see unigrams and bigrams here that are common across at least some of these job titles. And that was one of the key insights. Well, the key insight was actually doing the analysis on this and finding that unlike job titles, where there's a really fat tail, the n-grams appear across different job titles very frequently. And there's a very sharp drop-off. It's a cliff practically. You go after the first, let's call it a few hundred n-grams in a given job category, and after that, the n-grams don't reappear very often anymore. which was this amazing insight, because that meant that if we could somehow figure out the semantics of all these n-grams and then use them to infer the semantics of the job titles, we could very quickly come up with a system that produces this, which is exactly what we want. And by the way, this isn't unique to job titles. There's lots of categories of entities that have this pattern where the n-grams repeat over and over again. Like I said, we've applied the same technique to, well, I'll get into it, but to university majors, degrees, skills, and we're looking at a whole bunch of other things. Obviously, we're focused on professional data because that's our business. I'll leave it as an exercise to the rest of you to figure out what are other domains where you could apply some of the approaches that we'll be talking about here. So specifically for job titles, what do we have to do? So let's say this is a job title. What we want to do is we don't want to just build synonym tables, because that's not enough. Especially if you want a high quality search, you want to do some sophisticated analysis on them, you need more meta information. So this is just a subset of the label types that we care about, but we're looking for job title, we're looking for specializations, we're looking for certifications. And this is what I'll use for examples today, but there's actually a couple others as well that we consider. So let's talk about this, the ICU registered nurse. What is this? Well, the job function here, it's nursing. And specialization, ICU, intensive care unit. And the certification is registered. This person is registered in some state to work as a nurse. It's great. So what does that mean? Well, first thing we want to do is actually break this term out into its n-grams before we can do the analysis. So there's 3 unigrams here, ICU, registered, and nurse. There are 2 bigrams, ICU registered, registered nurse, and 1 trigram. Great. Now what we're going to do is, instead of trying to apply the labels to the entire job title, we're not going to go top down, and actually we're going to go bottom up. So we are going to start and only label the unigrams, because oftentimes, just by looking at it, you can figure out what the semantics are for if you're focused on a domain. So in this case, ICU means specializations, ICU, registered nurses, nursing. This is a little bit of a trivial example. It gets more complex than this, but this will be simple, easy enough to follow along. So what we can do is actually manually label these n-grams. Because as I said earlier, the n-grams don't have this fat tail. So you could actually label, 1/100th or maybe 1/10th as many n-grams as you would have to job titles in order to get good coverage across the entire space. So if we manually go through it and just label these unigrams, then at least in this example, we don't even need to go bother labeling the bigrams, because what we can do is when we look at the bigrams, we just propagate those labels up, because we see, well, these unigrams appear within these bigrams. So just copy those over and just assume those must be the labels for those bigrams. And then we do the same thing for the trigrams as well. What this means is we can literally shave off roughly 1.5 orders of magnitude of labeling work to achieve the same thing. Now it's not quite that simple, because let's go through another example here. Let's assume you're looking at ICURN. Well, actually, this is kind of still along the same lines of thinking. So with ICURN, we know that, okay, well, we know ICU, we just labeled that. We don't know RN, so what do we do? Well, let's go ahead and introduce another unigram. Let's go ahead and apply the labels. Now, RN just stands for registered nurse. It's pretty trivial. So we add the job function, we add the certification labels. And then we just propagate those over. Great. Sounds dandy. Looks like we're going to be, we're in business. We're not doing too much work. But let's look at another example and see how that plays out. Well, let's say nurse assistant. That's interesting. Is this person really a nurse? So the labels would say yes, but no, we'd be wrong. No, a nurse assistant is actually a different category of person. This is someone known as a nurse aide. Now, a nurse aide is not a nurse. They're not registered. You know, they may have some kind of certification, but they're certainly not allowed to do things that nurses are allowed to do. So it is a very, very different kind of job title. So what we need to do is actually, instead of just labeling the unigrams, we have to go, no, we have to actually label this entire bigram. So now we have a bigram label known as nurse aide. And so what we actually do is we actually go all the way to the trigram level sometimes for job titles. And for things like university majors, we go all the way to the quadrigrams. But because what happens is semantics can change as you add more words. In terms of the algorithm we used, I'm not going to go into too much detail, but it's very much a greedy algorithm. So the way that works is you start with a job title. In this case, let's call it Intensive Care Nurse BSN. Oh, that sounds fancy. What does it mean? Well, first, do we try to match the trigrams? Are there any trigrams that match? In this particular case, no, there aren't. Okay, next we try for the bigrams, and then the unigrams. So what do we end up with? Well, with intensive care nurse, we know that intensive care actually means, you know, it maps to ICU. This is a label that we've defined. There's many different n-grams that might have this particular label. Hence, when I say we're mapping things to a common semantic space, it's these labels that are the common semantic space, and that's where we actually understand what things mean. And then we can label nurse, and then interestingly enough, we can label BSN. Now BSN, knowing nothing about healthcare, you may not know what it means. It's actually, I think, a Bachelor's of Science in Nursing, and that is a prerequisite in order to become a registered nurse. So if someone has it, it basically means they're a registered nurse, or they're about to be. So that's how we would label this title. Now, why trigrams? Why do we stop at trigrams for job titles? Why do we even go that far? Why not bigrams? Why not quadrigrams? So let's look at another example to explore that question a little further. So let's say you have a title, Assistant Director. Now, assistant and director are pretty different things. If you look at just the unigrams, they're radically different. Directors, you know, typically a pretty senior person within an organization. Assistant typically is not. But you take it together, and it actually is someone who's maybe like half a step or a step below whoever the director is. It's actually someone who's very senior. So in that sense, because we have these semantic modifiers where, you know, one word, a single unigram by itself means one thing. Combine it with another unigram, now it means something else. Same thing, you can add one more, a third, it could mean something else entirely. Let's see what that looks like. Assistant to the director. See, we just added another unigram, changed the meaning again. So this kind of goes to why we need to have, that too is tricky, right? We need to have trigrams for job titles. But there's other issues here, right? Two, in a lot of, if you're doing information retrieval, it's typically considered a stop word, right? Like, well, wait a minute. And in fact, there are a lot of stop words in job titles. If you just include everything, it's going to be a mess. So it requires a little bit of domain expertise here, and we've had to analyze it for every new domain that we've been applying this technique and understand, well, what stop words do we have to keep because they're semantic modifiers, and which ones can we throw away? So things like in or of, turns out, are very extremely common in job titles. Those we can toss out. But to and for, like the example we just saw, we have to keep those around. We also strip out almost pretty much all characters, all special characters as well. And however, for universities, university data, so education, like people often have very, very, very long degrees, right, when they put it on their resume or their profile, because often what they'll say is, you know, I have bachelors of science in computer science and minor in business, emphasis in entrepreneurship. Anyway, there could be easily like 8, 10, 15 word degrees or majors, whatever, as what people will list. And they're often not broken out. And it's not clear where one ends and the next one begins. So if we want to use this approach for majors, what we found is we actually do have to go to quadgrams. So we make that call on a case-by-case basis. So let me give you an example of like what the actual output looks like. Because what we've done is we built a bunch of tooling around this in order to make this process very, very quick and efficient. So in the end, we end up with something like this, where you have this nice, beautiful graph. This happens to be a clinical research job category within the biotech industry. And we've got a whole bunch of these. We call these industry trees. We actually built a series of tooling so that we can have a data analyst go, do a whole bunch of research. It's probably like 70% of their work is research. And then 30% is using some of the tooling that we built to define these industry trees and all the labels, and then the system then figures out how do we get job titles or skills or majors to map within structures like these. Here's a couple more examples. Here's supply chain management. Here's marketing. But what do we do? I mean, this is like a boatload of work. And if we were just using Excel spreadsheets, this would be incredibly inefficient. So how do we do it? So what we've done is created a tool to help Simon fly called Manifold. I'm going to do a live demo of that tool. Hopefully everything goes smoothly. All right. Oh, actually, give me 1 second. I got to turn on mirroring so I can see what I'm doing. Apologies for the task switch. Okay. Where is it? There we go. All right. So this is Manifold. It's got fearsome animals on every load. Okay, that's not an animal. I don't know. We're pulling off some Tumblr feed somewhere. Anyway, let me show you what a typical workflow looks like. So the researcher will go, data analyst rather, will go and spend a bunch of research into a particular job title. Let's say we're doing consumer packaged goods. Let's say marketing. And first thing they do is they actually have to figure out what the canonical job titles are. So we don't figure that out for them. They have to bring in a certain amount of domain expertise and say, okay, well, I've looked at a whole bunch of company jobs pages and a bunch of people's professional profiles, and I figured out, well, there's a concept of brand manager and marketing officer and copywriter. So I know we're cheating a little bit here because I know a lot of the more fancy approaches will actually figure out what the canonical entities are. Well, that will eventually add that as well, but right now this was kind of the expedient thing to do. So we let them actually input them themselves. Then another manual task where they can actually search across our database of hundreds of millions of job titles. Actually, in the US, it's just single-digit millions. And just find, very, very quickly find all the ones they think are relevant and add them for consideration. And I'll explain what that means later. But remember, we have to go and actually label a whole bunch of unigrams, bigrams, and trigrams. Where do we get those n-grams from? Well, this is where we get them from. The data analyst goes, does a bunch of keyword queries, gets ideas for job titles that we should consider labeling. Over-labeling is okay, because that'll get handled on the back end. Well, you want to make sure you're not missing too much. It's actually okay to miss some things because, as I mentioned earlier, these n-grams appear over and over again in different combinations. So even if you miss 50 or 100 important job titles out of many thousands, it's okay. Odds are you're going to find a whole bunch of n-grams that occur in those job titles anyway, and you'll get good coverage. And then the next couple of steps are, well, first you have to go and label the canonical job titles. So this is actually the labeling process. Product manager is one of the canonical job titles, and you can start saying, oh, this is the job function, this is the specialization, etc. We have nice autocompletes. We can very, very quickly go through a whole bunch of this data. In that case, it's just this one page, and then so on and so forth. Then we go to unigrams, and again, we can very quickly label a bunch of unigrams, label a bunch of bigrams, and before we know it, we've got all the input data that we need. One of the things you might notice here is we have some of these are red and some of these are gray. We've added a concept of negative labels, and this is a hint to the algorithm. So a negative label might mean that, well, if these two terms occur simultaneously, it means you're definitely not this thing. And that happens because sometimes when we combine, let's say a title is 3 terms, 3 words, but we don't have that whole trigram labeled. We only have its 2 bigrams labeled. Well, in that case, those 2 bigrams can have conflicting meanings. So then we can have the negative labels help override those. And once we have this, we will create something known as that we call a label set, where we go, bring all of these together, and actually start doing some of the analysis. So let me give you an actual example of what this will look like. So we've done all this labeling, we feed it to the algorithm. The algorithm produces nice results like this. So what are we looking at here? In green, these are the canonical job titles. And these are the ones that we manually defined. In gray, these are the ones that the algorithm figured out, well, actually, they all map to this same canonical. And then on the right are the labels. Now, one thing you might notice is, wait a minute, all these labels are different. In fact, for each one of these, they're unique relative to the labels on the canonical and from each other. So actually, there's a lot more meta information. Even though these are essentially synonyms, we still have captured the subtle differences between them. And if we wanted to only do searches by job functions or queries, aggregations by job functions or specializations, we can do that. However, what's missing here is the fact that there's actually a lot more going on here. So if I expand one of these, wait, there's even more. So what happens is, what you see here, this is what we call a representative job title. It means that every job title that's grouped under here has exactly the same combination of labels, and this one, the one that we're showing to the surface, just happens to be the most frequent one. That's the one, and hence it's the representative for those semantics that one represents. And that's actually really useful. So the reason we have this screen even is because this gives us an opportunity for the analyst to very quickly scan through the results, because they just did a whole bunch of domain-specific research and actually see, is this correct or not? Because one of the things about semantics is the machine is not going to tell you what something means, right? How do you prove that it's correct? It's kind of impossible. So what we've done is we've given our data analysts tools they need so they can, using their own human intelligence, very quickly browse through it and understand, is this correct, or is this a mistake and needs to be adjusted somehow? And in fact, I don't have access actually through here, but what there is a whole review process where, hey, a reviewer can add comments, say, hey, this is not quite right, fix this. Someone directly from the screen can make adjustments, and then it'll dynamically reclassify everything and show you, hey, here's how things changed. So we could very, very quickly iterate on this and only occasionally look at, well, what's actually happening under the hood, because the representative job titles capture a lot of the meaning that we're looking for. So this is Manifold, and to date, we've classified we've done about 20 industries, and we've created well over 100 of the industry trees that we've talked about. Let me actually show you what those look like. Hierarchies. So, yeah, here's the clinical research one I was talking about. But anyway, we've actually generated over 100 of these, and that represents a couple thousand canonical job titles, which represents tens of thousands of representative job titles, which represents hundreds of thousands of what we're calling like raw job titles in the wild. So we still don't have complete coverage, but we actually, from a like, US employment standpoint, we have good coverage of about 55 to 60% of the population in the US with the work that we've done so far. And instead of it taking hundreds of man years, as we had projected initially, with this approach, we've probably put in about 5 or 6 man years worth of analyst time into doing research and adding labeling work. Obviously, we have several people working in parallel to come up with these kinds of results. And we've also done the same thing for skills, university majors, university degrees. So it's gotten actually quite sophisticated. Now we're looking at other applications beyond just resume-style data. So that's the high-level approach. That's Simon and Manifold, and open for questions. Go for it.
So the manual label that you mentioned, is it only applied to the unigram, and then you kind of build the bigram and bigram from that?
So the analyst can choose at what level to apply the labels. They start with unigrams, and then if the semantics change at the bigram or trigram level, they will add additional labels for bigrams and trigrams.
So on the example you give, like assistant director,
Yeah.
it started with the labeling assistant and director, two separate things, and then the whole bigram will change semantically in terms of the label. So is that the human would detect that, or is the algorithm that prefer that these two assistant directors is a different kind of from the assistant director?
Right, so one thing I'm not able to show right now is we have something called a black box validation. So that the screen of like results of canonicals and all the job titles and maps to them, we call that white box validation. As in you're looking inside the box, you're seeing what the algorithm produces. We have a black box validation process that detects conflicts like that, where it's like, hey, someone just got assigned 2 different job functions that came up from 2 different unigrams up to this bigram, and there's something wrong with that. And then it'll direct analysts to take a look and say, hey, do I need to make an adjustment here or not? So the detection of a conflict happens automatically, but then actually doing something about it requires analysts to intervene. Yes, yeah, we tried that quite a bit. The problem is, the problem that we found is, so about that we spent a bunch of time trying to do an unsupervised approach before we settled on, pretty heavy manual approach. And what we found, particularly with job titles and also the other categories of data, is there's all these annoying unigrams and bigrams that will appear that actually don't have that much meaning. But they'll throw off all these algorithms, and we couldn't find a way to effectively exclude them. Or if we did exclude them, then there were other contexts where they did have meaning, where excluding them meant we'd actually break something. So it was this whack-a-mole problem. We weren't able to solve it. The quality was okay. It certainly wasn't going to give us the level of precision that we have here. So if you see this is color-coded by job function, we could almost, not quite, get job function level groupings, but not at the actual job title with the unsupervised approach. But even the job function level grouping, the quality was poor enough that we never took it to production. Yeah, it's definitely feasible. If all we wanted to do, this is something we've built using this technology, is an applicant recommendation system. So I'm working at Workday right now. One of Workday sells HR and financial software to large companies, like thousands of employees, hundreds of thousands. A common problem they have is these companies will get hundreds of thousands to millions of job applicants every single year. They'll only be able to screen maybe 10% of them. So if you assume qualified candidates are uniformly distributed, means 90% of their most qualified candidates are never getting looked at. So what we've built using this technology, Simon, is a way to analyze the job descriptions, analyze the resumes, and only recommend the most relevant candidates to the top. So you're focused on, you know, the 1 out of 10 candidates that are most likely to be qualified. We could, and we did, build that system, or try to build that system, using the unsupervised learning approach, where we just do clustering based on n-grams and job titles. Even like, we even did things like look at co-occurring job titles. Where it's, well, if you're a programmer at one company, you're a software engineer at another company, maybe that means, hey, they're somehow related. We spent, and again, unfortunately, because, and even that was problematic because so many people made career transitions that were totally unrelated that threw a bunch of noise into the data as well that we couldn't resolve. But using the Simon-based approach, we get really high quality recommendations. So we're finding our recommendations are generally significantly better than any recruiter would do, and better than the average hiring manager. Meaning, like, companies don't need to be doing resume screens anymore, assuming they did a diligent job drafting a job description, which is very often not the case. Go for it. Sorry. Awesome. This is patented, by the way, so don't copy it directly. Mm-hmm. Mm-hmm. Right. So I guess just to restate the question, if we know that, you know, these 2, 3, 5 different profiles on the web are actually the same person, and they're talking about themselves in different ways, can we use that information to figure out that these different representations of who they are and their job title actually mean the same thing? And maybe even use that to power an unsupervised learning approach. What we found was that it's actually very difficult to match people across different sites. So oftentimes they'll have a link. So if, you know, people will have a link from the LinkedIn to their GitHub, or from their about.me page to like everything. But there wasn't, we couldn't find enough of this strongly linked information to be able to like actually feed it into an algorithm and make sense of it. It actually turned out to be the opposite. What we could do is, even though people will represent themselves in different ways on different sites, we can use the fact that we can normalize their professional information. In fact, we can normalize almost everything. We had location normalization and company normalization. And using that normalized data, we can then use that information to match people across different sites. That's how we're able to do that aggregation. That's how we're creating the single identity of record for people. So it's a chicken and egg problem. Like, once you have that, you could probably use it to solve this problem at scale. The problem is you need it solved before you can do that grouping. Go for it.
Do you have any problems with ambiguous job titles, director of development in one industry, fundraising in another, engineering, and you have to classify the industry that you're in first?
Exactly. We do have that problem. So when analysts do the labeling, they do it in the context of a particular industry. Meaning, exactly the same job titles might get labeled 2, 3, 20 times. And that's okay. Because then what we do at runtime is when we get information about a user, we can, because we also have company normalization, we can look up the company, and look up that company's industry, and then select the appropriate set of labels to apply to that person's professional information. Yes?
How do you come up with a list of industries that work with
That's a great question. I think there's no good industry list and there's no industry list that's right for everyone. For our purposes, we started with something called the like GICS, or I forget what it's called exactly. I think it was created by Goldman Sachs and S&P 500 to categorize public corporations. And then we extended it to include the whole nonprofit and government sphere. And then we condensed it because it was something like we ended up with around 70 industries, and in practice, what we actually work with is closer to 30 to 40. So we had to kind of manually curate it in terms of, and the way we define industries was the structure and nature of jobs was different. Some industries are actually very similar, but if there's enough differences, we'd go ahead and say, no, what, they're different industries, and we're going to go ahead and do a separate labeling effort for them. Yes? Yes. So how do we select the most appropriate labels for a given job title? I didn't really go into too much depth on that, other than I said, well, we have this greedy algorithm. We try to match trigrams first, then bigrams, then unigrams. It's more complex than that because, like I said, we have the labels partitioned by industry. So what we actually do is, on a per industry basis, try the labeling. And we have a scoring function. One of the things we realized is, at least for job titles, and then we have a slightly different scoring function for every domain, but for job titles, the job function label is the most important one. If there is no job function label, it's worthless. Like, what you have is seniority and a certification, but you don't know what the person does. In which case you're probably wrong anyway. So we then discard any set of labels that doesn't have a job function. And those that do, we score them. And job function's the most important to have and then having a specialization is more important, and certification. What happens is, if you have two sets of labels and one has more matched labels than another, we'll pick the one with more and better matches. Also, if it's otherwise ambiguous, like the scores are pretty close, then we look at what industry does this person work in. Sometimes it's identical, like development director. You're going to get that like perfect matches in multiple industries. So that's when we look at a person's company and then try to disambiguate from there. So there's kind of a multi-step process, a bunch of rules and heuristics, and it works out pretty well. By the way, this is more of a starting point. We do have a plan to eventually employ probably dynamic programming to optimize the label matching process, but we haven't fully worked that out yet. Yes?
How do you deal with ands in this title? So they're a clinical scientist or a clinical research and trial?
Yeah, great question. So we consider and the stop word, so we just throw it out. And when we do see an and in a job title, because we throw it out, we'll just end up labeling both aspects of that job title. So if you're a clinical director and research scientist, you will have the two different job functions potentially, and that's okay. If they're within the same industry, it's pretty common for people to have multiple roles, and so that's valid. Yes.
Would you use different lists of stop words for different industries?
No. We haven't found the need. I think what we found is and of a handful of other things. We have a pretty short list, actually. I don't remember it offhand, but it's on the order of half a dozen words that are stop words that appear frequently and don't really add semantic meaning. They're just how humans happen to phrase language. But yeah, so basically, which means actually we are including most things that you would consider a stop word. Yes. That is a great question. So how do we deal with seniority keywords like director, where depending on the region, or actually even depending on the industry, even depending on the size of the company, can mean very different things. If you're a director at a startup, you may have 0 reports. If you're a director at a public corporation, you might have 50, 100, 1,000 reports, depending on how they're structured. Or you could be actually leading the whole organization, depending on what industry you're in. We don't do that very well today. So one of the things, because we partition things, all the labels by industry, that tends to emerge naturally. But even then, within the tech industry, we have no way of knowing that a director at Google is much more senior than a director at whatever startup that just got funding yesterday.
Size of employer doesn't give you a signal?
No, size of employer would be a great signal, and that's something that we've kind of been on our roadmap to implement, and we just haven't yet. But it is a challenge. We've actually looked at size of employer, and it's been quite difficult to even based on that make that work well. Yes.
The current technique being English-centric, have you looked into the extensions to such languages as Spanish, where actually control now, or German, where what we have as bigram will become proper unigram?
Yes, we have looked at them. In those cases, tokenization can also be a challenge, like with German. Like, how do you German, you'll just have like one giant word. How do you actually break it up into meaningful n-grams? Fortunately, there's some good libraries for that seem to work well enough. I think anecdotally, we've done a few experiments, and it looks like this approach will work. We're actually trying a different approach, though. Instead of hiring and training a bunch of analysts that do domain-specific research in every single language that we want this to work, which, by the way, we're working on this now, we're instead pioneering this translation-based approach. We're going to hire translators, which just translate the job title from, let's say, German or Spanish to English. And then we're coming up with some graph-based algorithms, some graphical models that will infer what the n-gram labels should be, so that we could use a small number of translations and infer the labels of n-grams, and we could use the n-grams to then label a much larger set of foreign job titles. Anyway, I can't talk about the technique we're using because we haven't filed a patent yet, and the lawyers at my company would kill me if I did, but I'll probably, in a few months I'll be able to talk about it. Cool. Questions? I think we're way over time. All right. Thank you, everyone.